Algebra 1, number 6.6. This is factoring by grouping. Some polynomials have 4 terms. The distributive property can help us factor some of them, not all of them. When there's no common factor for any of its terms besides a 1, we can factor terms separately. When we factor a polynomial by separating it, it's called factoring by grouping. So let's see how this is done. We've got x to the third power plus x squared plus 2x plus 2. There's no common factor between them besides a 1, and that doesn't count. So we can factor the x to the third plus the x squared separately from 2x plus 2. See? We factor them separately. So the x to the third plus x squared, we can pull an x squared out because they both have an x squared, and what's left over is 1x plus 1, see? And we can factor the 2x plus 2 as 2 times x plus 1. Now we can see they've got a common factor, don't they? They both got x plus 1. When we put it all together, we get x squared times x plus 1 plus 2 times x plus 1. Now we can use the distributive property again to factor out that common factor, x plus 1, that they both have. Let's get rid of one of those, okay? And these colors are going to show us how to factor out the x plus 1. So if you look, we've got our x squared times x plus 1 plus 2 times x plus 1. We want to factor out the x plus 1. So we put it here. See? We put one copy here because we've got 2, don't we? We're just going to put 1 here, and we're going to put this x squared plus this 2 in the other one as our other binomial. That's it. Wasn't that easy? Piece of cake. You can do this. Okay? Let's try it again. Now we've got 6a to the third power minus 9a squared plus 4a minus 6. We separate it into 2 groups. We put the 6a to the third minus 9a squared into one group and the 4a minus 6 in the other group. We factor them separately. We can pull out a 3a squared out of here because they both have a common factor of 3, don't they? And that's going to give us a 2a minus 3 inside the parentheses. See? When we multiply these together, we get the 6a to the third. And when we multiply these together, the outside ones, we get 9a squared. See? We can factor the 4a minus 6 as a 2 times 2a minus 3. We can factor out that common factor, that 2a minus 3. So this is what we do. It's written all together with a plus sign between these two. See? And our 3a squared and our plus 2 go back here into their own parentheses as a binomial factor, and the 2a minus 3 that we had 2 of, we just put it here, see? So easy when you look at it with the colors, isn't it? All right, let's try another one. We've got b to the third plus b to the second plus b plus 1. Now what happens when we've got like a b plus 1? Okay, we still make 2 groups. B to the third plus b to the second is in one group, and then the b plus 1 is in the other group. We're going to factor this b to the third plus b squared. We can pull a b to the second out of each of them, can't we? So we're going to end up with b squared times b plus 1 for this one to be factored. And this b plus 1 can be a 1 times b plus 1, can't it? So we can have a b plus 1 in parentheses like that one. That's what we're trying to do, okay? So now we can factor out this common factor, b plus 1. And the colors show us what happens. We've got our b plus 1 here, and we've got another one there. So we put one of them here, and we put the b squared plus the 1 in its own parentheses as a binomial factor, and we're done. See? Let's try it again with a little bit harder one. Now we've got x to the third plus 2x squared minus x minus 2. So now we have a minus between them. All the other ones we had a plus in between our groups. So now we got a minus, okay? We still make 2 groups. And look what happens. We can factor the x to the third plus 2x to the third as x squared times x plus 2. So that one we can do, okay? If we use the distributive property, it should get us back to that one, okay? For our x minus 2, we're trying to get an x plus 2 in parentheses. So we can do a 1, because see, here's a minus sign. We can do a 1 times negative x minus 2. Or we could put the minus sign in the front here, like it is here, and do x plus 2. See? Because it's the same thing. If we did 1 times x, we'd get a negative 1, wouldn't we? And if we did 1 times negative 2, we'd get a negative 2, right? It's the same thing as having a negative 1 times x and a negative 1 times positive 2. Same thing. But if we write it this way, we'll have the x plus 2 that we're trying to get in parentheses, okay? So that we've got 2 of them so we can factor it out. So now we factor out that x plus 2. When we write this one and this one together with the minus sign in between them, we get x squared times x plus 2 minus 1 times x plus 2. Now we can take the x plus 2 and put it in its own parentheses right here, just one of them, and the x squared minus 1 in the other one. We're done. Okay? Now, this one can be done in 2 ways, so I'm going to show you both ways, okay? Look at this one. We've got this x squared y squared plus ay squared plus ab plus bx squared. Now you notice that there's a y squared here and a y squared there. So we can pull that out right away and do y squared times this x squared plus that a. See? So what we're doing is we're pulling these out to be put in the parentheses, and we factored out the y square in the front. See that? And then for this part, they both have a b here, so we're going to factor out the b, and we're going to put it in the front here, and then we're going to put the x squared plus a here. See? So that we have an x squared plus a like we do here, because we're trying to get 2 binomial factors that are the same. See? So we don't want to put a plus x squared, because this is x squared plus a, right? Now, you know what we're going to do. We've got this and this that are identical, and we're going to put them by itself as 1. And then we're going to put the y squared plus the b in the other one as the other binomial factor, and we're done. All right? But look at what we can do. All right? Because there was a y squared here and a y squared here, we pulled it out, right? And we factored it out. Well, there's also an x squared here and an x squared there. So we could pull it out as an x squared and factor out the x squared first if we wanted to, instead of the y squared. See? It still would have worked. So in this case, we'd have x squared pulled out. So we're going to pull out that x squared, and we're going to pull out this x squared, and that's going to give us a y squared plus b, because this is all plus, see? So commutative property says it doesn't matter what order we add them, right? So we can use this one plus this one, see? To get this first one. So now we're going to do y2 plus the b, see? And now we've got these 2 left over. So in this case, we grouped the first term and the fourth term together, see? In this one, we did it like we did all the other ones. We did this term together and then this term, see? So if they're all pluses, you could use commutative property because it's all going to equal the same thing, right? And associative property says we can just group them any way we want, right? So both properties work. So now we've got an A and an A for the last 2 terms, so we can pull that A out and factor with the A and end up with y plus b. See? I think that's supposed to be a squared. All right? So we end up with our y, yeah, it is squared. We end up with our y squared plus b and our y squared plus b, and it moves down to its own parentheses as a binomial factor, and then we put the x squared plus a into the other one, see? Yeah. So either way it'll work. I tend to think this is easier because you're kind of going in order, but if for some reason you see that you think it would be easier to factor the first one and the last one, then do it, because it's okay because of the commutative and associative property, all right? Now, this is what's really important. Check this out. if we've got x to the third plus x to the second plus 2x minus 2, and we regroup it so that these are together and these are together, we can factor out the x to the second power, can't we? And have x to the second power x plus 1 for this side. And we can factor out the 2 for this one and do 2x minus 1. But it can't be factored like we've been doing because this is a plus 1 and that's a minus 1. So this is a polynomial with 4 terms where it did not work. So it doesn't work every single time. We can't use this factoring by grouping for all of them. Okay? It just works for some of them. All right? Okay, I hope this was helpful and I hope it wasn't too confusing. If it was, maybe you can try watching it again because I gave lots of examples, but I hope the colors helped. And we're going to move on to our next unit. We're going to talk about general strategy for factoring. Okay? I hope I'll see you there. Bye.